Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Here's the essay, Introduction, the 1985 contribution by Harry Kroto, Richard Smalley and Robert Curl, resulting in the discovery of Fullerenes, represents a singular achievement in chemical science. Their work, emerging from investigations into the products of laser vaporization of graphite, presented a compelling explanation for the presence of extraordinarily stable carbon clusters. This essay undertakes a systematic evaluation of their original findings, interrogating the core claims, methodological approaches, and internal consistency. The aim is a detailed analysis of the arguments presented within the work, assessing their validity and enduring significance within the broader context of scientific progress. This investigation prioritizes an exhaustive examination of the original publication itself, rather than external or peripheral facts. Section 1, Introduction to the research and its primary question. The authors, in the introductory segment of their publication, immediately set the scene. They describe their initial motivation to understand the formation of carbon chains and rings in the interstellar medium. The central question arises: how can one produce these carbon structures under laboratory conditions suitable for mass spectrometric analysis? This sets up the experimental framework wherein they subjected vaporized carbon to observation, seeking to mimic astrophysical environments. Their initial hypothesis is that the interaction between laser-vaporized graphite and a helium carrier gas would yield carbon clusters mirroring those hypothesized to exist in space. This leads to their presentation of the mass spectra, which become the central evidence for the discovery. The introduction is clear on scope, directly indicating the aims of the experiment and its relationship to broader scientific problems. Section 2, Mass spectrometric observations and the emergence of C60. The crux of the paper is the detailed presentation and interpretation of the mass spectrometric data. The authors reveal sharp, prominent peaks at specific master-charge ratios, differing from what one might have predicted based on previous studies of carbon clusters. The most striking feature is a pronounced signal at a mass of 720 atomic mass units, corresponding to a molecule composed of 60 carbon atoms, designated C60. This observation, occurring in abundance, is crucial. They observe other clusters too, confirming the patterns. Crucially, they did not observe C58 or C62 in significant abundance, indicating a special stability for C60. They interpret this as a fundamental structural property related to the arrangement of carbon atoms within the cluster. The data are presented with accompanying discussions of the instrumental setup and verification of signal presence. The authors also present the observed trends in intensity as a function of the number of carbon atoms, setting the stage for their structural interpretation. The meticulous reporting of experimental conditions, alongside the clarity of the data display, stands as a key component of their argument. Section 3. The structural proposal, a truncated icosahedral. The authors propose a structural model explaining the unusual stability of the C60 molecule. It revolves around the concept of a highly symmetric structure, a truncated icosahedron, now widely known as a Buckminster Fullerene or buckyball. They invoke an argument based on the geometry of the truncated icosahedron, which, by virtue of its fivefold and sixfold symmetry, is both aesthetically pleasing and structurally stable. The model describes a structure composed of 12 pentagons and 20 hexagons. The paper specifically points out that such a structure, where the carbon atoms reside at the vertices, would have all carbon atoms equivalent. Each carbon atom would participate in 3 bonds, resulting in a stable closed shell, thus explaining the observed stability. The elegance of the model, linking molecular structure to symmetry principles, is a key aspect of its appeal. This link between the data and the geometrical model forms the core of their theoretical argument. The authors do not shy away from the fact that their structural proposal is based on the experimental evidence. They do not introduce the model as a foregone conclusion, but rather as a reasonable, yet radical, hypothesis. Section 4. Elaboration on the stability argument. The explanation of C60's stability continues. The authors elaborate, explaining how the specific structure, possessing only pentagonal and hexagonal faces, minimizes the energetic strain within the molecule. They highlight the absence of dangling bonds, which would predispose the cluster to reactivity. The argument hinges on the known stability of hexagonal carbon arrangements such as those in graphite, and the added stability arising from the close, spherical structure. This addresses the question of why such a structure would form preferentially, and why it would be remarkably stable under harsh conditions. The paper also explores other potential structures that might accommodate the experimental data. They assess these, but return again and again to the truncated icosahedron as the best available descriptive. Section 5. Extension to other carbon clusters and implications. The authors extend their interpretation to other carbon clusters. They show that clusters with other even numbers of carbon atoms, such as C70, also exhibit enhanced stability, though to a lesser extent. They point out that a similar structural argument can be applied to the higher symmetry, and the closed-shell structures render those molecules similarly stable. The introduction of these further examples offers additional support to the structural idea of symmetry-driven stability. Furthermore, the authors briefly discuss the implications of these findings for astrophysics, suggesting that Fullerenes could exist in interstellar space. This discussion remains speculative and, crucially, is secondary to the core argument about the structure and stability of the observed carbon cluster. Section 6. Experimental methodology and its justification. The essay must address the experimental methodologies. The authors explain the use of pulsed laser vaporization of graphite, followed by expansion into a supersonic helium jet, and mass spectrometric analysis. The choice of these techniques is carefully explained. The laser vaporization approach provided the high temperatures needed to vaporize the carbon. The helium jet allowed for rapid cooling of the carbon clusters, preventing their aggregation and facilitating the formation of specific cluster sizes. The mass spectrometry offered a sensitive tool for detecting and quantifying the various carbon cluster sizes. The authors carefully describe the instrumentation, ensuring the community can fully understand the setup and, indeed, replicate the experiment. The paper's rigorous attention to experimental detail is crucial for demonstrating the reality of their observations. Section 7. Evaluation of claims data interpretation. A central point in any scientific work centers on the ways in which the data are interpreted. The author's interpretation of the mass spectrometric data is critical, with the peaks at specific master-charge ratios being central to their argument. The interpretation relies on the accuracy and calibration of the mass spectrometer. The author's discussion on the sources of error remains limited. While the peaks are clear and distinct, there could be small peaks arising from the presence of impurities that the authors do not discuss. Moreover, the author's initial assumption of the clusters being composed of only carbon atoms is a critical element of their claim. The agreement between observed mass and calculated masses for specific carbon clusters is compelling. Yet, it is here the author's interpretations are given the most. Section 8. Evaluation of claims structural model and symmetry argument. The structural proposal is a central element. The truncated icosahedron, or Buckminster-Fullerene, is ingenious. Its predictive power rests on its high symmetry and closed structure. The authors offer no direct evidence, experimental or otherwise, for the specific structure of C60. The arguments for this specific model rest instead on its aesthetic appeal and the theoretical expectation of stability. The argument suggests its geometry, a consequence of its unusual symmetry, allows for a stable structure. The paper acknowledges the limited evidence and stresses the need for additional investigations to verify the precise structure. The authors, thereby, are not claiming certain knowledge. They put forth a hypothesis based on the experimental data. Section 9. Impact and legacy. The impact of their findings is immense. The discovery of Fullerenes opened a novel research area and continues to influence fields from materials science to nanotechnology. The observation of C60 and the subsequent structural proposal provided an entirely new class of compounds. This discovery spurred immense interest in carbon-based materials. The work's rapid uptake by the scientific world suggests the compelling nature of the arguments and the excitement surrounding the findings. Indeed, the subsequent confirmation via various spectroscopic and microscopic techniques validates the claims. This section, however, must not overlook any problems that researchers found. The simplicity and elegance of the buckable model proved to be difficult to accept for some. Section 10. Contemporary reception and subsequent studies. Initial reactions to the claims were initially mixed, a perfectly understandable outcome from scientific innovation. The authors faced some skepticism. The primary obstacle lay in the radical nature of the claim. Fullerenes represented an entirely new form of elemental carbon, a departure from known allotropes. Despite the initial challenges, the remarkable consistency of the experimental results, combined with the elegant structural model, helped to establish the validity of the claims. Additional analytical methods confirmed the data and helped the science move forward. The work has been extended over the years. The development of methods for producing and manipulating Fullerenes has allowed researchers to probe their properties and applications. Researchers have refined understanding of the growth mechanisms and the reactivity of these novel molecules. Section 11. Internal coherence and logical framework. The paper's internal coherence is a notable strength. The structure logically guides the reader from the initial observations to the structural proposal and the implications for other carbon clusters. The arguments are laid out with careful precision, supporting one another. The authors acknowledge weaknesses, such as needing to establish the precise structure, the use of appropriate terminology, and the clear demonstration of experimental techniques further strengthen their argument. The framework is consistent throughout. The experimental observations provide the foundation. Then, the interpretation of those observations allows for the conceptual framework. The buckable. Section 12. Limitations and alternative explanations. Consideration is needed for possible limitations of argument. While the data for mass spectrometry shows clear evidence for C60, it does not offer direct proof of the proposed truncated icosahedral structure. Different models could exist, yet the author's emphasis on the geometric considerations does make the model compelling. Any alternate explanation must account for the experimental evidence. These limitations are balanced by the remarkable match between the predicted and observed master charge ratios, and the subsequent confirmation within other studies. Conclusion. The 1985 work by Kroto, Smalley, and Curl, which announced the discovery of Fullerenes, constitutes a pivotal contribution to scientific understanding. The essay has demonstrated the logical coherence of their arguments, from experimental observations to the structural proposal. Their presentation of mass spectrometric data is clear and persuasive, offering compelling evidence for the existence of C60, the structural model based on a truncated icosahedron. While initially speculative, is elegant and consistent with many subsequent studies. The author's acknowledgement of the limitations of their claims and the clear exposition of their experimental methodology are evidence of robust scientific practice. This work not only unveiled a new class of molecules, but also fundamentally challenged preconceived notions about the stability and structure of carbon. The discovery of Fullerenes opened pathways for advancements across various areas of science. Their legacy, a remarkable example of scientific innovation, rests on the power of observation, insightful interpretation, and the enduring quest for understanding.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.